Okay. All right. Hello, everybody. It's so great to see you all since 2020. We're here finally in person. So, as Bill said, Bill already gave intro. I'm an ML engineer and artist, MLGD for MLGD, and I'm also a community leader. I lead GDG Seattle and Seattle Data Analytics and Machine Learning. So Sage, the co-organizer, he was here earlier. He had to leave early, but I also run Seattle Data Analytics and Machine Learning. I really enjoy art and design, so I spend a lot of time practicing drawing and painting. So it's been a while since I speak to you all, like 3 years in person, so you probably don't know this. I actually spend a lot of time on drawing and painting. Also this past year, I took on 3D fashion design study at Parsons School of Design, which is one of the top design schools in the world. It's very challenging. You know, I have my day job, right, doing machine learning, but in my spare time, I also study 3D fashion design, and I find that 3D is very interesting. I also spend a bunch of time on 3D deep learning as well. And I use this software called Flow 3D to create these 3D fashion design. So today, my talk is only 30 minutes, and I'm squishing in a lot of content. Two main things I want to talk to you about, popular trend. One is generative art and design, which I have been talking about generative art and design for the past few years. But this year, I think most of you have heard of diffusion models, right? All of a sudden it got so popular, right? So I will touch on that. And then the second thing I will talk to you about is on-device machine learning. Some of you probably have heard of my talk before talking about TensorFlow Lite, and so I will touch base on that. And then in the middle, I will also talk a bit about training with TensorFlow 2 and Keras, just to briefly touch on that. Okay, first topic, generative art and design. So art and design is a very broad topic. You know, art is not just images, it could be music or video. And design could be product design, fashion design, graphics design, UI, UX design, and so on. So my talk, 30 minutes, I'm gonna just touch on some of it. So first I'm gonna go over kind of the trend from the beginning, right? You heard about diffusion model these days, you heard about GANs, but where did we start with? I would say Deep Dream back from 2015 was probably one of the very earliest examples of using AI for art, right? It was experiments to visualize the patterns is learned by neural network, similar to how a child watches clouds and try to interpret random shapes, and Deep Dream over-interprets and enhances the pattern that it sees in the image. So 2015. And then 2015 we also have image style transfer. Raise your hand if you heard about style transfer back then when it was really popular, right? And when you see like, oh, two pictures got combined. Here's a dog, and then here's some other pattern, and of course, you know, Van Gogh's painting, and then it got combined into one image. This is pretty interesting, even though it's from back 2015, 7 years ago, right? I include a link. You can read about how the developer wrote about the details, because it's really important to understand these basics, right? And before we come to today, how the generative models actually work. So what are generative models? It's basically take a machine, you know, Ian Goodfellow says, take a machine, observe many samples from a distribution, and generate more samples from that same distribution. And there are different generative models. There's GANs, I'm sure most of you have heard of at University of Training. And there's a variational autoencoder, the flow-based model, and of course diffusion models that have become really popular the past year or so. And I want to talk about generative adversarial networks, GANs. How does it work? Typically, the simplest kind of GANs have at least two networks which compete against each other. You have this generator and discriminator. And you know, generator, this one takes the random noise, make the fake image, and the discriminator takes the real images, the training image plus fake image, you know, say if it's real or fake. This is basically a classifier. You know, if you know machine learning, you know what a classifier is, and it keeps giving the feedback to the generator will make better image. So that's the gist of it. And then diffusion model. How does it work? Diffusion model really gained the popularity in recent years. And how it works is basically by gradually adding the Gaussian noise to training data, then try to learn to reverse the process to generate the image from the noises. So this is the forward, and this is the reverse process. And I've included a link here. It's a pretty good NVIDIA blog talking about this. This is my sketch notes. I like to take notes by hand and draw. So people, they like my sketch notes because I spend a lot of time on this. It's pretty, but it also captures the essence of the notes. You know, you're learning something technical, right? You read a paper or whatever. So here, I summarize GANs and also diffusion models. Now, it does not include all. For those of you who have worked with the GANs before or just read about articles, there are a lot of GAN variants, right? I included some. They tend to build upon each other, either try to solve a particular training issue or create new GANs architecture for finer control of the GANs or better images, right? And I have also included a bunch of other things like GPT-1, 2, 3, and the style clip, DALL-E Glide, DALL-E 2, Imagen, Google's Imagen, Stable, which Clive is going to be talking about in his talk later, and then the Stable Diffusion that got open sourced in August this year. That become very, very popular. So this is a kind of like the timeline of generative models. And now I'm going to talk about a few things that I find kind of interesting. This is not a new paper. It's been a few years, but I just want to point out the Fashion Plus Plus. We hear a lot about generating images. This is not about generating images, but rather to recommend whether an outfit is fashionable or not. I thought that it's very interesting. And here is a real-world example of how a business would use generative art and design, actually for the business. So if we have any designers here, and you probably know when you design, you take the design assets from Icons 8. Take a look at their website. You will notice that the GAN applications that they're using, Smart Upscaler, Generated Photos to Face Generator, etc. Here is another example of how generative art and design can be applied to a real-world application. Photoshop uses a lot of the AI to enhance images, such as adjusting the facial expression, age, lighting, pose, and it can also transform landscape images by changing attributes such as time of the day or the season. So here is text to image. For those of you who've heard of GANs, a lot of times GANs can work with like music as well, but a lot of it you hear about images, right? Well, we can also generate images from text, and the style clip is such an example. And using text as the input is more flexible and intuitive, using text instead of using the class label as the condition. And combining the NLP and computer vision has become a really popular research in the recent area, especially the diffusion models that we're talking about. They all also use the large-scale language models in there. And text-to-image, here's another example. It's a VQ-GAN plus clip. And VQ-GAN is a type of GAN, a vector quantized GAN, and the clip stands for Contrastive Language Image Pre-trained Model, and it's from OpenAI. And so this last year, I was also giving a talk on generative art and design, last November. Back then, VQ-GAN plus clip was perhaps the most advanced techniques back then that was free and open to everyone. Designers and artists will go try to run a collab using this. And it was like super slow, it takes a long time. It does generate some images, but that was last year, right? Fast forward to now, 12 months later since then, we have diffusion models, especially since the Stable Diffusion was released in August. They are able to generate high quality photorealistic images at a very fast speed. I have included this tweet here, as well as I'll share my site with you. So, if you look at the link to the tweet there, there are like 14 notebooks that you can actually go run and put in some words and then create images yourself. So how many of you have heard about Stable Diffusion? A lot of you. Okay, great. So try out the notebooks. I'm sure you enjoy them. Like I said, 12 months ago, DQGAN plus clip, painfully slow. Now, lots of these notebooks. And all of these notebooks, they basically are using this model published on Hugging Face, right? But they write additional code to run the inference to generate images. I also included examples here. This is Keras Stable Diffusion tutorials using the Keras CV computer vision library, and check it out. This is very good because the other notebooks they might be using PyTorch, and these are using Keras and TensorFlow. So here's Francois' tweet about Stable Diffusion available, etc. One thing I want to share with you is if you go to this website called the Lexica, because when you try to generate the images from text to images, it's all about the prompt. What prompt do you actually use to generate a good image, right? So if you go to this website, you can search with some keywords, and then you look at the images that get generated. On each image, if you click on it, you can actually see the details of the exact prompt, and how that will help you to actually be able to generate the nice images, right? Because it's not just about a particular object. Sometimes you also describe what type of image you want to generate, or which artist, or what style you actually want, which is kind of similar when we actually create art or design, right? You want to know what the object of the sketch is, and then you kind of want to know what kind of style it is. Is it Van Gogh style, or is it just anime style? Okay, wait. Hang on just a second. I'm trying to. So, I think this one is kind of out of place. I meant to talk about this later on, but I think I'm going to just skip it for now. If I need to come back, I'll come back later. So the key takeaway on generative models is that I think the diffusion models actually truly democratize the generative AI, because before that we did have the generative AI and the models, but typically you have to be really technical, be an engineer or machine learning engineer to have access to it. But with this, the artists and designers actually have access, right? And the AI will assist the artists and designers and give them inspiration, because in the process of creating art or create design, having the inspiration actually is a very first step and very important step. And then, non-engineers have access. Everyone can create art and design, but does that mean everybody can be artists and designers? That's a good question, debating question. For me, in my opinion, creating art is also about the process. It's not just about the end result. All right, now I'm going to switch gear to talk about how to train a GAN model with TensorFlow 2 and Keras. And I'm going to be really quick zipping through this just because the talk is very short. This is a DC GAN example with Zalando fashion. How many of you have heard of fashion and this? Yes? Okay, so fashion this is 28 by 28 grayscale images. They actually come from the Zalando fashion. These are bigger colored images. And step by step, you need to get the data and you write the code for the generator, discriminator, and then you put together the DC GAN, the callback, and end-to-end training. This is with Keras. And to prepare data, you just download the clothing and models from Kaggle, because it's from Kaggle, it's ready for training. All you have to do is just resize it to 64 by 64 and pre-process the range of -1 to 1. And then to create a model in Keras, you can use sequential or API or functional API or model subclassing. Sequential API is the easiest, functional more flexible, and model subclassing the most complex one, but it's also the most flexible one. The generator, as I showed you before, the input is the random noise, and then the output is some fake images. And you add the layers to upsample a few times in the generator architecture, and then you output a generated image. And the discriminator is just a classifier, right? So the input is a real or fake images, and then you downsample a few times, and then the output is 1 or 0, real or fake images. And then the DC-GAN model itself, we're actually overriding the train step here. We actually subclass the model class. As I mentioned earlier, subclassing model class is the most complex one in terms of creating the model class. And here we're overriding the train step here, and then train the discriminator and generator simultaneously. And then we calculate the loss. We have to calculate separately the discriminator loss and generator loss. And then we also monitor the loss and the images visually that get created during the training. And then we save a model. So here we're saving the model, H5 Keras model here. I wrote a bunch of GAN models, tutorials here. You can go to this link and look at the details that I wrote for PyImageSearch, published on PyImageSearch. Okay, now I'm going to talk about the model inference with TensorFlow Lite. And here is the second point that I'm trying to make today, is really running inference, model inference on the edge. It's really a very important trend for machine learning. So for TensorFlow Lite 2, TensorFlow 2 has standardized the model saving with the saved model, or Keras model that you can deploy to all of these places. And if you want to deploy to IoT, microcontroller, edge TPU, you convert it to TFLAT format. So what is TensorFlow Lite? How many of you heard of TensorFlow Lite? Oh, wow. Okay, a lot of you have. Great. So TensorFlow Lite, for those of you who don't know, sometimes people are like, oh, can I write the model in that? So TensorFlow Lite is not a framework like TensorFlow versus PyTorch, that sort of thing, right? You don't write code in TensorFlow Lite. It's actually a framework that has a set of tools for deploying machine learning model to mobile, embedded, and edge devices. It has a lot of components, converter, interpreter, ops, kernels, interface hardware, accelerator, and a bunch of tools. Quantization, pruning, benchmarking, and model maker, like a bunch of tools that does not fit anywhere. It's just part of this TensorFlow Lite, right? But if you're just starting out working with TensorFlow Lite, chances are you work with the converter, changing it from a saved model or a Keras model to a TensorFlow Lite model format. And then chances are you're also working with the interpreter, right? Like if you're running it on Android or iOS or on some edge devices. And here's just a really quick Android app, putting it on TensorFlow. So you can train your own model or find a model on TensorFlow Hub. And then if you train yourself, you have to convert it to TFLAT format. You run the inference in Python, and then you benchmark it, and then you add the model metadata yourself. Now, all of these steps, if you use the model maker from TensorFlow Lite, you don't have to worry about this. It's just a few lines of code in the TensorFlow model maker. And then build the Android app, you create a UI navigation, you input the image, and then you load the model and run the inference, and you display the result in the UI. Now, when you try to build an application, the pre-processing and the post-processing is probably the hardest part, because the interpreter already takes care of the running the inference part, right? So the TensorFlow Lite team also tried to improve upon this process. So there's like the Android Studio ML model binding, meaning that you just drag a TF-like model in there, it will create all these classes for you, the boilerplate classes for you. There's also another way is the task API, which writes the C++ code, again, pre-processing, post-processing, all the boilerplate code, the hardware. You can use the task API to do that as well. So one thing to point out, if you do implement a GAN model on, say, Android or some device, you only need to implement the generator part because the discriminator is only for training, and the generator is actually the only thing that you will use for inference. A couple of examples here that you can run ESR GAN on Android with TF Lite. This ESR GAN basically super res will make a blurry image more clear. This one is one of the projects that I worked on. Selfie to animate. You can take a picture and then, or actually just point the camera at yourself and take a picture, and then we'll create an anime. And then there's another project that I worked on. There are two models. One is a segmentation model. Here it will segment out the